Okay, our next topic in trig is the angle sum and difference formulae. I'm going to write these in sort of an abbreviated way. I've got the first one written down here, and I'm going to talk about the shorthand that we use, just because the formulas are for addition and subtraction are basically the same as each other. I don't want to have to write out a bunch of different formulas. And if you look on your formula sheet, you'll see the shorthand here, but let me sort of explain what it means. So for any sine of any angle, we can break it down into two different angles. And you'll see in a second when I do some examples, but this might be helpful if, for example, I want to figure out what the sine of 105 degrees is. Well, there's nowhere on my unit circle where I know exactly what that is, but I do know what the sine of 90 is, and I do know what the sine, and I can figure out what the sine of 15 degrees is. So using those two things added together, I can actually figure out what the exact value of sine of 105 is. I'll step through an example here in a minute. Okay, so the first one is sine of a plus b, where a and b are two angles, is equal to sine of a times cosine of b plus sine of b times cosine of a. The difference formula for sine is exactly the same as this, except for if it's a minus b, then it is sine a cosine b minus sine b cosine a. So this plus minus sign here just means that these added together, right, means I'll use the plus here, and the minus here means I'll subtract those. Okay, the cosine formula for a plus b is cosine a cosine b minus sine a sine b. Okay, now see how these two signs are opposites? So then the way that this one works, the way that we note this, is that we put a little a plus or minus b. This sign right here, we just put the minus on top and the plus on bottom. So what that means is, when you see these symbols, is whatever this sign is, we use the opposite one right here. Okay, so if it's cosine a minus b, it'll be cosine a cosine b plus sine a sine b. All right, the tangent addition and subtraction is tangent a plus tangent b all over 1 minus tan a tan b. Okay, so this one's a little bit trickier, but notice this sign and this sign are the same, and then this sign and this sign are different. So the subtraction rule, tan a minus b, will be tan a minus tan b, and 1 plus tan a tan b. Now notice that for this rule there's some domain limitations, right? We can't use any place where tan a or tan b is undefined, which there are points, there are angles that give us undefined, and we can't have any values that are going to make the denominator equal to 0. Okay, so let me do a couple of different examples just to show you why we might want to use this. So let's say that we were asked to find the exact value of cosine 75 degrees. Okay, well, we don't have anything like that on our unit circle. We can't just look right at our unit circle and see what cosine 75 is. We can plug it in our calculator. It's not going to give us the exact value. It's going to give us an approximation. But here's the thing. on my unit circle, I do know the exact value of cosine at a couple of angles that I can turn into 75. So if I think of, instead of thinking of this as cosine 75, I think of it as cosine 45 plus 30. Then I can find the exact value, because I do know the value of cosine 45, cosine 30, sine 45, and sine 30, and that's the things I all need to know to use this formula. Okay, so just using the formula now, it's going to be cosine 45 times cosine 30 minus sine 45 sine 30. Okay, cosine 45 is root 2 over 2. Cosine 30 is root 3 over 2. Sine 45 is root 2 over 2. And sine 30 is 1/2. Okay, then simplifying this down, root 3 times root 2 is root 6 over 2. And those two are just going to give me, over 4. And then these two multiplied together is root 2 over 4. Since the denominators are the same, I can just put my numerators subtracted together on top, and I get that as an exact answer. Okay? So there's one example. What if I was asked to find something like sine 15? Well, I can think of that as sine 45 minus 30, because 45 minus 30 would equal 15. Okay, so plugging that into the sine formula, I'm going to take sine 45, multiply that by cosine 30. I'm then going to subtract off cosine 45 times sine 30. Okay. All right. Sine 45 is root 2 over 2. Cosine 30 is root 3 over 2. Cosine 45 is root 2 over 2. And sine 30 is 1/2. Okay. This should look very much familiar. These two things are exactly what I had up here. So I'm going to end up with exactly the same answer. Now this should make sense because 75 and 15 are complementary angles. So if I were looking at my triangle, right, where this was 75 degrees, this would be 15, and the cosine of this would be adjacent over hypotenuse, and sine of this would be opposite over hypotenuse. Those would equal the same thing. Okay, I think for the most part, this is just plugging things into a formula, which I know for me isn't super exciting. For some of you it is. I think that for the most part, you just need to practice using these. Just make sure that you're using the signs correctly. And when you see these formula, just know that, like, if this sign's like this, but in here it's upside down, it means I need to do the opposite here than what I had right here. And I think that's good enough to get you through what you need to be able to do 5B, assignment 2. And I think that's it. I will see you next time.